Thanks, Jen. Well, at least I won't have to explain what the CAPSTONE program is. That's a good start. Yeah, my name's Dave Messner, and I'm with Orbital ATK. It's a local space components company in Goleta, so it makes sense from a geography standpoint why we've had such a long affiliation with UCSB. I graduated from UCSB, mechanical engineering, so I'm very comfortable with the university. So I am going to talk a little bit about our experience with the mechanical engineering CAPSTONE programs in particular. But first I will give just a brief description of Orbital ATK and who we are and the kind of things that we do. All right, so ATK and Orbital merged in February of this year, so you can tell by the logos that we have now merged because a lot of work went into trying to merge an Orbital and an ATK logo. So yeah, I think it took about 25 minutes to generate that logo. The combined companies are about $4.5 billion. The full Orbital business merged with the aerospace and defense divisions of ATK. There was a commercial ammunition division within ATK that is spun off as its own private company. But now Orbital ATK is very much a space and defense company. There's about 12,500 employees, and there's offices throughout the United States. Orbital ATK is divided into 3 operating groups: a flight systems group, space launch vehicles, rocket propulsion systems. So Heritage ATK, shuttle rocket booster type solid rocket booster technology, as well as the rockets that Orbital Sciences has made, Pegasus rockets, Taurus, and Antares, these flight vehicles that they make. There's a defense systems group, which is really straight over from the former ATK, and then the space systems group, which consists of commercial satellites, government satellites, spacecraft components, which is where we're located in our location in Goleta, as well as some technical space services. All right, so talking about Goleta in particular, the company was founded in 1975 in this area in Goleta, making deployable space structures. We like to think of it as mission enabling for many of the projects that we've been involved in. There's a picture of our facility. We're on Pine Avenue here in Goleta. We have what I think of as a very experienced team of engineering, primarily mechanical engineering personnel, with good capabilities in precision assembly and integration and test activities. We're pretty small. We have about 80 people in our Goleta office, but we've done some pretty big things, I think. And in our 40-year history, we've maintained 100% flight success on all the things that we've done, building deployable structures for various applications. Over here you can see we built the deployable booms that deployed the solar arrays on the space station. We've built support structures for various antenna systems. You may recognize these round solar arrays are actually being developed for the Cygnus vehicle, which is doing cargo resupply to the space station. Some other things here, we built the 12 ship sets of solar arrays for Boeing for GPS-2F, and the note there says 9 out of 12 ship sets successfully deployed. 9 out of 9 have been successfully deployed. There are 12 total that we delivered. There's three spacecraft that have not yet been launched, but we built all the solar arrays for that. So we don't make the photovoltaics. We buy the photovoltaics and we integrate them on our systems. But I got the new Jen and the Institute here of Energy Efficiency through some of the work that we do with building solar arrays, because this is really our primary product that we make in Goleta. It makes about 60 or 70% of our revenue, so it's the primary product. We built a solar array called UltraFlex, which landed on Mars several years ago. We have another set of 2 wings that we just delivered. Actually, they left the building yesterday to be delivered to Lockheed Martin, which will then be integrated with a spacecraft that's a JPL managed program for another flight to Mars to do more studies looking for water and those kinds of things on the Martian surface. But our solar arrays that we built provided primary power for the lander. If they don't deploy and operate as they're supposed to, there's no mission. So it's that 100% flight success I talked about is very important. I mentioned the deployable booms for the space station. We built 8 of those. They're 30 meters long. And space station's approaching 15 years of service, still going strong. We have hardware that we built for a shuttle mission that's actually in the Smithsonian, Dulles Annex. That is a partially deployed, that's about 30 feet of deployed mast. It was a fully deployed, it was 200 feet long for a shuttle mission that had an antenna at the tip, antenna in the shuttle bay, and it did topographic radar imaging of the Earth's landmass. And there's a picture of the data product. This was one of the first things that that was actually mapped and finalized by JPL, and they sent this to us. You may recognize that little peninsula right there. That was of the Santa Barbara area. Okay, so talked a little bit about the company, and now I want to talk about really a lot of the collaboration that's happened between UCSB and Orbital ATK over the years. Really, since I would say about the early 90s is when the collaboration really began in earnest, and primarily with the mechanical engineering department. About 25% of all of our employees are UCSB grads, and again, most are mechanical engineers. We have been a part of the Mechanical Engineering Industrial Advisory Board, so coming on, learning about what's happening within the department, offering input to try to help, the department get better, as well as understanding how the department and our company could work together. So I worked with a lot of the faculty and got to know the people and understanding the curriculum and things. We lecture and have guest lectures here, and mutual, there's a lot of visits and things back and forth. So the proximity has always been a really a positive thing for us. All right, so the CAPSTONE program in particular, again, senior design projects that are a year long and there's various projects that are selected. Industry can work with the UCSB to actually help define the projects and then also act as mentors for the students doing these projects. So offers really good collaboration opportunity. Over the last 10 years or so, I would say that the CAPSTONE courses have really grown in significance. I think that most of the departments have CAPSTONE courses now, but I think mechanical engineering was one of the early ones of adopting it, and has grown the program. And coincidentally, the mechanical engineering department's rankings nationally have improved since the time that this project was really established, and has become a positive thing. Being a part of the IAB, one of the things we learned was that in 2004, the ME department set a goal of being in the top 10 rankings in 10 years or 15 years from now. 10 years from now, they achieved their goal 5 years early. I just got a 2-minute heads up, so it caught me off guard there for a second. Anyway, the CAPSTONE program, it's a great teaching tool, a great opportunity to collaborate, and it's been a really good thing, both I think for the students that participated as well as the people in my company that's been mentoring and things. So the program receives high marks through the accreditation program, and it provides an excellent context and practical application for the undergraduate students. They get excited about the various programs they work on. And from an industry standpoint, you get a chance to meet the students and help your employees actually get some training and things and working in teams and things. So it gives them a growth opportunity as well. So there's some check marks for the CAPSTONE program. And just going back in time, some of the projects that we've actually been affiliated with, that we've worked with the students on, we use a lot of composite structures, so programs related to using the materials that we use, couple programs related to that. We've done some of our release mechanisms that we use for our deployables. Some mechanism work, trying to improve those devices. A damper, controlling the rate of the deployables that we have. We have to control the rate and how we do that. And a team worked on trying to develop a better damper for our use that we could implement. And in each one of these the cases, we get to know the students, and they really do develop a relationship. And I really like that picture there, because here we got all these guys, these team members all wearing these shirts. They all had the logo, company logo on it, and things working together. And that's actually one of our guys, one of our employees right there, although he looks like he fits in pretty good with that group. And this particular team took first place in the poster competition. Summarizing, I think the CAPSTONE course is it's a great project, both for the university. It's helped the department get better, and it certainly is a great collaboration tool for to get to understand the students and get to work on projects that have mutual benefit for both what the students are trying to do and trying to apply what they're learning, as well as for companies to get value out of the actual projects that are being worked on. So it's mutually very good program, and we're happy to be a part of it. So it's been a good deal, and we'll continue to support. So thank you.